Imagine water flowing at a constant rate through a pipe. Now imagine that the pipe slowly narrows, which means we have a tapering pipe, where the cross-sectional area of the pipe change along the length of the pipe. Then what happens to a fluid when it flows through the narrow portion of this tapering pipe? Does it slow down or speed up? Does the pressure of the fluid increase because it's being squeezed here? Or does something else happen? This is a classic question in fluid mechanics, and while the answer might seem surprising at first, it's actually a direct outcome of basic physics principles. In order to understand this, first comes the idea of continuity, which just means that whatever fluid goes in must come out. Imagine you're pouring water through a funnel. If the top is wide and the bottom is narrow, but the same amount of water flows through each part every second, then clearly the water at the narrow end has to move faster to keep up with the constant flow rate across the pipe. That's all the continuity principle is saying. If we assume the fluid has the same density everywhere, which is true for most liquids like water, then the mass flow rate is just the cross-sectional area of the pipe multiplied by the velocity of the fluid. So at any 2 points in the pipe, if the fluid is steady and not leaking anywhere, then the area at point 1 times the velocity at point 1 must be equal to the area at point 2 times the velocity at point 2. If the area becomes smaller, the velocity must become larger to keep the product the same. That's why fluid speeds up in narrower parts of the pipe. Awesome! Now, let's look at pressure. When we ask people what happens to the pressure in the narrow part of the pipe, they say the pressure decreases in the narrow part because of Bernoulli's principle, which is this formula, and because velocity is more at point 2, pressure is less at point 2, that's it. But this kind of response doesn't really explain anything intuitively. It just states the result using a formula, without touching on why this happens or what's really going on underneath. This is where energy comes into the picture. Bernoulli's principle, or Bernoulli's equation, is just a way of saying that the total energy of the fluid stays constant as it moves along a streamline. The energy can change form, but the total remains the same. In this case, the energy in the fluid is stored in 3 ways: pressure energy, kinetic energy, which comes from speed, and potential energy, which comes from height.